Hey class, this is Miss Cornett, and I've had a few questions about classifying real numbers, so I thought I would just make a quick video for you, and hopefully this will help you out as you're doing your homework for section 1.1. I have two different visual pictures for you to help try to understand how all of these different sets of numbers work together. Everything that we're going to do in this class, we are always going to work with real numbers. There is such thing as imaginary numbers. You probably took an Algebra 2 class or pre-calculus class in high school where you had I as an imaginary number. We are not doing any of that kind of math in this class. This is just talking about classifying real numbers. The smallest group of real numbers is right here in this inner circle that I'm coloring in green. It's called your natural numbers. Natural numbers are when you first learned how to count as a child. You started with 1, 2, 3, 4, 5, 6, 7, on into infinity. You did not include 0. You did not include any negative numbers. So any number that simplifies to a natural number would simplify to a value 1, 2, 3, 4, 5, 6, 7, and so on. There's only one number that's different from a natural number to a whole number. A whole number is a group of numbers. It includes all of the natural numbers, your 1, 2, 3, 4, 5, 6, 7, and so on. Plus, it includes the number 0. Integers in this purple circle also include your set of natural numbers and your set of whole numbers and all of your negative whole numbers. And now notice the bigger circle, rational. A rational number includes all of the natural numbers. It includes all of the whole numbers. It includes all of the integers. Plus, it includes terminating decimals, repeating decimals, and any fraction that simplifies to a terminating decimal or simplifies to a repeating decimal. Everything else that's not rational it goes into a bucket by itself called irrational. They're still real numbers because we're not talking about imaginary numbers, but this smaller group is called irrational numbers. The most popular irrational number is pi. Remember from high school, it's like 3.141569, something like that, on and on and on and on. That's the most popular irrational number. Irrational numbers are when you punch something into your calculator and the decimal seems to never stop. It fills up your entire screen. It's not repeating, so you can't stop it with a repeating bar. That's what's called an irrational number. Another very common irrational number is when you take the square root of a non-perfect number. Okay, so remember basic math. A perfect number is a number like 1 or 4, 9, 4 times 4 is 16, 25, 36, 49. Those are your perfect square numbers. When you put a square root symbol over the number 49, it equals the whole number 7. If you put a square root symbol over most numbers like 46 or 51, if you punch that into a calculator, it's going to give you some long decimal. That's an irrational number. Okay, so first question, which ones are natural numbers? Natural numbers is back to when you were a kid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, or any number that may simplify to one of those numbers. Look at the first one. 6 over 1 in its most simplest form equals 6. So this one is a natural number. Negative 6 over 18. Its simplest form is negative 1/3, so we're not going to include that one. The negative of square root of 11, I don't know what the square root of 11 is, but it's going to be some long decimal, so we are not going to include that one. The square root of 36 is 6, and 6 is a natural number. Negative 1. Is negative 1 a natural number? Can you imagine like your little kid brother or sister or cousin counting and including negative 1 in their count? No. Same with negative 8.98. That is not a natural number, but 77 is. Okay, next question. Determine which of the numbers are in the set of integers. Okay, think about integers. It's all of your negative numbers, negative, and 0, and all of your positive numbers. Really sloppy, I'm sorry. Okay, so go back to the same list of numbers. 6 over 1 simplifies to positive 6, so yep, that's an integer. Negative 6 over 18, it still simplifies to negative 1/3, which is not an integer. The negative square root of 11, it still simplifies to a really long decimal, so that is not an integer. Square root of 36 is positive 6, so yes, we can check that one. Negative 1, yes, that is a negative whole number, which is an integer. Negative 8.98, nope, that's a decimal, and 77 is an integer. Okay, next it says determine which of the numbers are in the set of rational numbers. Okay, rational includes almost every real number out there. So we're going to check more on this one. Okay, same list of numbers. 6 over 1 simplifies to 6, which that's a natural number. 6 is also a whole number. 6 is also an integer, and it's also a rational number. Next, this simplifies. Negative 6 over 18 simplifies to negative 1/3, which is a fraction. It's a repeating decimal, and so we're going to check that for rational. The square root, anything that's a square root of a non-perfect number, that's always irrational. So we're going to skip that one. The square root of 36 is positive 6. Negative 1 is a rational number. Negative 8.98 is a rational number, and so is 77. This question, determine which is an irrational number. Well, it's pretty easy. We can go back to this last screen, and we selected everything except negative square root of 11. And so the only irrational number is right here, negative square root of 11. Let me go back to the first picture real quick because I didn't quite explain all of these buckets from this very first page. If you look at the very top, the natural numbers, which are your 1, 2, 3, 4, 5, 6, 7, 8, and so on, all of those are also, they dump into the whole number bucket. 0 is also a whole number. That's actually the only number that makes a natural number different from a whole number, is the number 0 itself. Then the natural and whole number bucket dump into the integer bucket, which inside the integer bucket are all of your negative whole numbers. And then all three of those buckets all dump into the rational bucket, which inside the rational bucket is also your terminating decimals, your repeating decimals, and any fraction that simplifies to repeating decimal or terminating decimal. And then all of that dumps into your real number bucket. And then you can see over here is that you have an irrational bucket. I hope this helps. I'm going to throw it out there and put it out on Moodle. Let me know if you have any questions.